Hello class, welcome to Algebra Lesson 1-2, which is all about solving linear equations. By the end of this lesson, you should be able to create and solve linear equations with one variable. So this is going to look really similar to things you did last year. By really similar, I mean this is what you did last year at some point. Okay, so solving linear equations, solving for one variable, okay? If I give you 26 equals 8 plus m, and I ask you to solve for m, many of you would recognize that means I need m to be all by itself. Now, there's a certain phrase that I use when I solve equations, so I'm going to introduce it to you. I'm going to use the phrase tee it up. This does not mean you have to use this method, but I like to draw an upside down t just to help me remember to perform operations on both sides of the equal sign. So if I know I need to move that 8, I have a positive 8, so to move it, I would have to subtract 8, and if I do it on one side, I have to do it on the other, and that t just helps me visualize that I've done it. So 26 minus 8 is 18 equals m, or you could write m equals 18. Both are correct. I tend to prefer to put the variable first, okay? Then looking at the next one, I'm going to tee it up again, and I have 8x equals 32. If I want x by itself, I have to move that 8. So what undoes multiplication? That would be division. So I'm going to divide both sides by 8, and I'm left with x equals 4. And that is my final answer. Moving on to the one down in the bottom left, I have y minus 13 equals 17. I've teed it up. If I want to get y by itself, I have to move that minus 13. And I move minus 13 by adding 13 to both sides. So y equals 30. And the last one, tee it up, and I have n divided by 5 equals 25, or n over 5 equals 25. To undo that division, I'm going to multiply by 5. So I'd say times 5, and I have n equals 125. And that is it for example 1. Just kidding. We have a little bit more with example 1. That was the super easy version. Now let's look at something that's a little more complex, where you have to do multiple steps in order to solve it. So you'll see the same problem listed twice here. And the reason I've done that is because I'm going to show you two different ways that you can solve this problem. Okay, so the first one, I'm going to say I want to get rid of the fraction. And the reason I'm going to get rid of the fraction, I'm not always the biggest fan of working with fractions. Sometimes they can be really nice. But in this case, since I want to get x by itself, I have to get rid of that fraction anyways. So the way you do that is you take whatever number's in the denominator and you multiply everything by it. So when you multiply this first entire fraction here, that just makes the 3 go away on the bottom. And then you're going to multiply over here so that minus 8 becomes a minus 24. And you're going to go all the way across the equal sign and multiply 32 by 3, which is 96. So I'm going to carry everything from the top of the fraction down. So this is what my problem would look like now that I have gotten rid of the fraction. So now I tee it up and I say, okay, I have 2 times the quantity of x plus 4 minus 24 equals 96. I'm going to start with the thing that's farthest away from that variable. So I'm going to move that 24 first. So then I have 2 times the quantity of x plus 4 equals 96 plus 24 is going to give us 120. Now, some of you might have said, why don't we distribute that 2? If you do that, that's fine. It's just going to add another step in the long run, though. So whenever you have a number on the outside of parentheses like that, I recommend you don't distribute it through. I would say take it, and you're multiplying, right? You would multiply it to distribute. So divide both sides by whatever number's outside of the parentheses. So then I'm just left with x plus 4 equals 60. And the last step to get x by itself, now it's easy. I just subtract 4 from both sides. So I have x equals 56. Now that I have x equals 56, I'm going to go over to the other method and show you another way to solve it. If you don't like getting rid of the fraction first, you could move the 8 first. And the way you move that 8 first would be to add 8 to both sides. So then I have 2 times x plus 4 over 3 equals 40. And then since we are dividing by 3 on the left, I'm going to multiply both sides by 3. And I have 2x plus 4 equals 120. And that might sound familiar because, look, these are the exact same thing. So when I divide by 2 and end up with x plus 4 equals 60, you shouldn't be surprised. Neither should you be surprised when I say minus 4, x equals 56. And I would say I am done. Okay, so you have 2 options on this type of problem. This happens on a lot of problems where you might start a different way than I do, or you might start a different way than your friend does. That doesn't mean you're wrong. It just means that you might be solving it a different way, and that's okay. Now, here is the problem I want you to try on your own. Good luck. Hopefully you ended up with x equals 4, and your work looks something like this. Like I said, you might have done something a little bit different, and that's okay, as long as you ended up at x equals 4. Now let's look at example 2. Example 2, I'm going to tell you right now, I love these types of problems. Hint, hint, it will be on the test. So make sure you're paying extra close attention, even if you've been kind of zoning out because you're thinking, oh my gosh, Miss Johnson, we've learned this before, move on. This is something that trips kids up every year, so don't let yourself be one of them. Consecutive integer problems are amazing, so let's break down what consecutive integer means. Consecutive, that word, means in a row. So if I'm talking about consecutive integers, I'm talking about numbers that are in a row. And integers means we're not talking about decimals here, okay? We're only talking about positive and negative numbers, right, with no decimals. Now, an example of consecutive integers would be 1, 2, and 3, right? They're all in a row. A non-example of consecutive integers would be 1, 4, 7. Those are non-consecutive, so those would not count. I could also say consecutive even integers, and I could say 2, then the next even integer would be 4, and the next even integer would be 6. Same thing for odd. I could say I'm going to start at 1, and then the next one would be 3, and then 5. And no, you don't have to always start at super small numbers. I could say 53, 55, and 57 could be my 3 consecutive odd integers. All right, so hopefully you're feeling okay with the idea of consecutive integers. So let's expand on what if our numbers were 1, 2, and 3. I would call my first number x because I actually don't know what my first consecutive integer is going to be in this problem. Because if you read the problem, it says the sum of 3 consecutive integers is 132. So I know if I had 1, 2, and 3, 1 plus 2 plus 3, that's 6. Those aren't going to be my answers, right? But the first one in the list, I'm going to call x. Then to get to the next number, I would take that first number and I would add 1, right? That's how I would go from 1 to 2. How would I go from 1 to 3? I would take that original number and I would add, not 3, sorry. I would add 2, right? 1 plus 2 would give me 3. So the way we represent our terms in consecutive integer problems, this is your first term, this is your second term, and this is your third term. Okay, so if I say the sum of 3 consecutive integers, okay, so sum means I'm adding things together. So I'm going to take my first term, and I'm going to add it to my second term, and I'm going to add it to my third term, and I'm going to say it equals 132. And that's how I would set up that problem. So now I just simplify and solve. I can see I have 3 different x's listed there, so I'm going to say 3x plus, and then I have a 1 and a 2. So 3x plus 3 equals 132. And then it's just like the problems we were working with. I would start farthest away from x, so I'm going to say minus 3, minus 3. 3x equals 129. And then to get x by itself, I would divide by 3. So I have x equals 43. Okay, so I know x equals 43, and a lot of you are going to be tempted to stop right there because you're like, I know what x equals. Aha, that is not the end, because I want to know what the 3 integers are. So if x is 43, that means my first term is 43. My second term would be 44, and my third term would be 45. When you're typing answers into Edpuzzle, feel free, or even writing them on a test, you can separate them by commas, just like this, okay? 43, 44, 45. And that is your answer, okay? I highly recommend, if you're not someone that takes notes, this is a page to take notes on. Like I said, I love these problems. All right, this time it is your turn, but let's take a moment to talk about this problem. The sum of 3 consecutive odd integers is 57. What are the 3 integers? So your first term would just be x. Your second term, if I was talking about odd integers, if I was going from like 1 to 3, I have to add 2, right? Because I have to skip that number. And then my third term, I would have to skip 4 numbers, because if I was talking about 1, 2, 3, 4, 5, these would be my odd integers, right? And the way I get to them is by using x, x plus 2, and x plus 4. So now, go ahead and finish setting this up and solve it. Good luck. All right, hopefully for an answer, you ended up at 17, 19, and 21. If your work does not match mine, or those are not the answers that you ended up with, feel free to reach out for some help. I'm more than happy to help you. Like I said, I love these problems. And you can also talk to friends, see if they know what's up. Let's move on to example 3. We have 4 friends use an online coupon to get discounts on concert tickets. They spend $312 for the 4 tickets. What was the price of 1 ticket without the discount? So you can see I'm monkeying around with the image so it fits on the screen. So here's the screenshot of their order, okay? Here's the information of prices. We know the total was $312. We also know that the discount was $15 on each ticket. So we want to figure out, how do we set up an equation for this? Well, there were 4 tickets bought, right? And we know we want to solve to figure out what the price of the ticket was before they had the $15 ticket discount. So what the friends actually paid was the original price minus 15, and their total was $312. So I have the 4 friends buy 4 tickets with $15 off each ticket, and their total is $312. Then from there, I'm going to divide by 4. Divide by 4, I end up with P minus 15 equals 78. Then I just have to add 15 to both sides. And I have P equals 93. So that means the original tickets were $93 each. Okay. If you have questions on that, please be sure to ask for some help. Here's another question for you to try on your own. The same 4 friends buy tickets for 2 shows on consecutive nights. Fun fact, we know what consecutive means now, right? 2 nights in a row. They use a coupon for $5 off each ticket. They pay a total of $416 for 8 tickets. Write and solve an equation to find the original price of tickets. You do not need to type the equation into Edpuzzle. just send me your final answer, okay? Good luck. Hopefully you ended up with an equation that looked like mine where 8 tickets were bought at $5 off a ticket. So you did P minus 5, that quantity times 8 equals 416. And when you solved that, hopefully you ended up at 57. If not, again, ask for help. I'm more than happy to help you guys. And this is the last example we're going to do. I'm not going to make you try a problem like this on your own. So this is the last part of the video, okay? LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes for the repair. Then she will ride her bike home. Can she be home in 1 hour? So you can see we have home right here, bike shop here, and we know that they're 1.5 miles away from each other. So let's say on the way there, so to bike shop. Let's figure out information with that. We know it's 1.5 miles, and we know she's traveling how fast. So on the way there, it looks like it's the red line. It's the, well, that I've highlighted lime green now. It's the walk at 3 miles per hour. So she did 1.5 miles at 3 miles per hour. Then we have to add in the time at the bike shop, right? The wait, which she said is going to be half of an hour. And then the way home, it's still 1.5 miles, right? But how fast can she travel on her bike? According to the map, she can bike 10 miles an hour. So we have to add all of those times together in order to figure out her entire time. The reason we want to figure out her entire time is we want to know, can she ride or can she be home from this whole journey within the hour? So if I do 1.5 divided by 3, I get 0.5. And then I already have a nice little decimal right there. And then 1.5 divided by 10 is 0.15. If I add all of those together, I get 1.15 hours. So she can't make it within the hour because it will take her 1 hour. And if I do 0.15 times 60 to find the minutes, I get 9. So 1 hour and 9 minutes is how long it takes her. So the answer would be no. Okay. So you have to add up all of the different segments of her journey. If you have questions on that, please be sure to ask for some help. But if not, I hope you have a wonderful day.